In our last video, we introduced radian measure. It's this new idea of measuring angles. 1 radian exists when our central angle cuts an arc equal to the length of the radius. That angle would then be 1 radian. So we use radian a lot in higher level math, but my brain still wants to function in degrees when I'm just talking about things normally, so our ability to convert back and forth between radian and degrees is important. Because maybe when we're thinking about it, we want to be in degrees, but then when we're actually doing math with it, we want to be in radian. So let's talk about how we convert between degrees and radian. We know the circumference of a circle is given by the equation circumference equals 2 pi r, where r is the radius of the circle. This formula shows us that the radius of a circle can be laid off 2 pi times around the circle, right? Since it's 2 pi times r, that means there's 2 pi radii that can be laid off around the circle. Therefore, an angle of 360 degrees, which corresponds to a complete circle, intercepts an arc equal in length to 2 pi times the radius of the circle. So, putting those two ideas equal to each other, we get that 360 degrees is equal to 2 pi radian, and that's going to be important for us. We can take each side of this equation and divide it by 2, and that's going to bring us to the fact that 180 degrees is equal to pi radian. That's important too, but I feel like knowing that 360 degrees is the same thing as 2 pi radian is critical. Well, we're going to use the relationship that 180 degrees equals pi radian to convert between radian and degrees. See, I could take this equation, this 180 degrees equals pi radian, and divide both sides by 180. And that brings us to the statement that 1 degree would be equal to pi divided by 180 radian. Similarly, I could have taken that same equation and divided both sides by pi, and that would have brought us to the conclusion that 1 radian equals 180 degrees divided by pi. Well, these are the two relationships we're going to use to convert between radian and degrees. We're going to start by converting degrees to radian. To do this, we simply multiply a degree measure by pi over 180 radian and simplify. So we're going to convert each degree measure to radian. We're going to take this 60 degrees, and we are going to multiply it by pi over 180, and then we're going to simplify. So I'd put this 60 over 1. Since we're multiplying fractions, we have the option of simplifying first by cross-canceling. So 60 goes in there once, 60 goes in there 3 times, multiply straight across, and we get pi over 3. So 60 degrees is equal to pi over 3 radian. Let's try another one. Converting negative 225 degrees to radian, we'll simply multiply by pi over 180. Since we're multiplying fractions, we have the option of simplifying first by cross-canceling. I see that 45 divides into both 225 and 180. So 45 is going to go in here 5 times. 45 goes into 180 4 times. And then I'm going to multiply straight across. Don't forget that negative that we had out here originally. We're going to get negative 5 pi over 4. You're going to do this, just like forever. Throughout trig, throughout calculus, we're going to need this ability to convert between radian and degrees. So now let's go, one more. (150 degrees), we'll multiply that by pi over 180. And then simplify. I see that 30 goes into both 150 and 80. So 30 goes into 150 5 times. 30 goes into 180 6 times. Multiplying straight across, we're going to get 5 pi over 6. Now we're ready to go the other direction. We are going to convert radians to degrees. So we're just going to multiply by the other version of this unit fraction. And remember, the term unit fraction just means a fraction that has a value of 1. And we know that 80 degrees and pi radian are equal measure, so it creates this unit fraction. Okay, to convert each radian to degrees, we're going to multiply by 180 degrees over pi. Now, sometimes it doesn't simplify out perfect. We might have to round our answer, and we'll do so to the 100th of a degree. So pi over 4. We're going to multiply that by 180 over pi. Since we're multiplying fractions, we can simplify first by cross-canceling. And notice that those pi's just totally cancel out. And then I can simplify 4 and 180. They're both divisible by 4. 4 goes in here once. 4 goes into 180 45 times. And then multiplying straight across, we get 45 degrees. You do need to put the little degree symbol there. With radian, as I mentioned earlier, it's unit free, so we don't put anything there, but the degrees, you do have to put the little degree mark. Let's convert negative 11 pi over 30 to degrees. We're going to multiply by 180 over pi and then simplify. Right, our pi's cancel out, and I can simplify the 30 and the 180. 30 goes into each. 30 goes into 30 one time. 30 goes into 80 6 times, so we're left with negative 11 times that 6. This is negative 66 degrees. So most of the time when you see a radian measure, it has a pi in it. And it usually, the pi is usually in the numerator. That's kind of like the dead giveaway that, we must be talking about radian. But every once in a while, you'll get a radian measure that does not have a pi, something like 5. And, that's okay. It happens. And we're going to work it the same way. But when I take this 5 and multiply it by 180 over pi, you'll notice there's no pi in the numerator here to cancel with the pi in the denominator over here. So when that's the case, you just have to multiply straight across and then divide, and we're going to round our answer to the nearest 100th of a degree. Multiplying straight across, 5 times 180. That's 900 over pi. And now we're going to divide by pi. And be sure that you're always using the pi key on your calculator. We should not be using 3.14 pretty much ever. We should always be using the pi key on our calculator. This becomes 286, and rounding to the nearest hundredth, that's going to be 48 degrees. In general, I think this is, once you do a bunch of these, it's relatively easy. It's just, like, sometimes in math, when things are really similar, it makes it confusing, because in one direction, the 180 is on top and the pi is on the bottom. And when we're going the other direction, it's just the flip. The pi is on the top, the 180 is on the bottom. So what I do to remember, like, where it goes is that I remember, in general, radian have a pi in the numerator. So if I'm converting to radian, then I'm multiplying by the one that has the pi in the numerator. And degrees typically does not have a pi in it. So to get rid of that pi in the numerator, I need to be dividing by a pi in the denominator. So that's just what I do to try to help myself remember which is which. But this is definitely something you're going to want to practice. We're going to be converting between radian and degree throughout the rest of your math courses. Well, now that we know how to convert between radian and degrees, we can use this ability to find exact values of trig expressions when the angle given is in radian. Basically, the first thing you do is just convert the radian to degrees and then go about your business as normal. After doing a lot of these, you might have some of them memorized, like I have all these ones listed memorized, but for now, really, that's all you're doing. Convert it to degrees, then find your exact trig value from there, like we have in the past. All right, so we want to find cosine of pi over 6. So I'm going to take that pi over 6 and convert it to degrees. We'll do so by multiplying by 180 over pi. I know that pi goes in the denominator because I wanted to cancel out the one in the numerator. So those cancel out, and then I can simplify the 6 and the 80, the 180. I mean, you could even go straight across first if you wanted. All right, so this is 30 degrees. So really, we're looking to find cosine of 30 degrees. So 30 degrees in quadrant 1. This creates a 30, 60, 90 triangle for us. The short side is across from the 30 degree, and we always label that x. The long side is the short side times the square root of 3, x times the square root of 3, and the hypotenuse is always 2x. And now we want cosine of this triangle. We know cosine is adjacent over hypotenuse. So that's going to be x square root of 3 over 2x. And we simplify by canceling out our x's, and we get square root of 3 over 2. Let's try another one. Next, we want to find cotangent of negative 3 pi over 4. So we'll start by converting to degrees. We'll take that negative 3 pi over 4 and multiply it by 180 over pi. Our pi's cancel. I can simplify the 4 and the 180. 4 goes in here once. 4 goes in here 45 times. So now when we multiply straight across, it's going to be negative 3 times 45, negative 135 degrees. So since our angle is negative, remember we start on that positive x-axis and then rotate clockwise 130 degrees. So we're going to be over here. We're going to drop a perpendicular to the x-axis and then identify our reference angle. This would be negative 180, so 180 minus 135 gives us a reference angle of 45 degrees. So we know we have a 45, 45, 90 triangle here. The two sides of a 45, 45, 90 triangle are the same. We label them both X. Note, since we are in quadrant 3, both will be negative. And then our hypotenuse is x times the square root of 2. It's coming from our special right triangles. So if you need a refresher on that, please go back and watch the special right triangle videos. And now we want cotangent of this triangle here. Remember that cotangent is adjacent over opposite. Our adjacent side is negative x. Our opposite side is also negative x. So cotangent of negative 135 is going to be positive 1. Let's do one more. Secant of pi over 2. We'll start by converting pi over 2 into degrees by multiplying by 180 over pi. Pi's cancel. We get 180 over 2. This is 90 degrees. So we're looking for secant of 90 degrees. When I draw this up, though, I realize, oh wait, 90 degrees is right here on one of my axes. So my special right triangles don't apply. Instead, we choose a point on that axis. To make our life as easy as possible, I always choose like 1. So this is going to be the point 0, 1. Secant, well, I can't really use my SOHCAHTOA definition here because I don't have an opposite and hypotenuse here. So I've really got to use my original definition with r involved. So secant is r over x. And this point gives us x and y, but not r. So we're going to have to do r equals the square root of x squared plus y squared to find that r value. So we're getting r to be equal to 1. Secant of 90 degrees is going to be 1 over 0. 0 in the denominator means that we're undefined. So secant of 90 degrees, which is the same as secant of pi over 2, is undefined.